Hello, everyone. We're going to get started. Welcome to the Autodesk Developer Summit. Super happy to have you all here. If you were with us this morning, welcome back. And if this is your first session, thank you for joining us. A couple of things before we begin. There will be a Q&A segment at the end of the session. You might have seen there's two mics in the aisles, I should say, not alleys. So at the end of the session, you can head up behind a mic and ask your question. If you have your cell phone on you, which I assume most of you do, feel free to put that in Please Do Not Disturb. And the session is also recorded, so if you were scanned on your way in, you will receive the recording after the show. So you're in for a treat today because you get to hear from not one, but two incredible Autodeskers. They're going to talk to you about a magical tool in Maya called Bifrost. You'll first hear from Sumira Dhawan. She's Autodesk's product manager for Proceduralism and Simulation. And then we'll hear from Guillaume Laforge, who is a software development manager also with Autodesk. So without further ado, please join me in welcoming Sumira to the stage.
So thank you, Robert, for the introduction, and thank you, everyone, for being here today. I'm really excited. This is my first time at GDC in person, and I hope you're having a good time. Are you? Good time? Okay, good. So we are here today to talk about Bifrost and how you can use Bifrost in your game development workflows. So Guillaume, after me, would be using a practical example and walk you through how you can build environments procedurally in Bifrost and then use it for your games. So before I dive in further, who here has used Bifrost before or has heard about Bifrost? All right, that's great. So you will be very excited to see what we have in place here. So what I'm going to do is I'll start with a quick introduction of Bifrost for new users here, and then I'll show you some core capabilities and new additions we have had in last few months. Then I'll hand it to Guillaume. Like I said, he'll show you more in-depth of how you can procedurally create environments, and then we'll leave some time for Q&A at the end. All right, has anybody seen this before? Many times, I'm sure. This is our safe harbor statement. It essentially states that we are going to make some forward-looking statement, and I will be showing some stuff that's only in beta. So we request not to make any purchase decisions based on what we are saying today or what we are presenting, because as you know, like any production, the schedule and plans do change. So let's dive in. What is Bifrost? Bifrost is a node-based visual programming for procedural 3D content creation. With Bifrost, you can do things like creating environments, doing simulation, procedural animation, and a lot of cool tools. Oh, is this stopping? Sorry. You can build machine learning networks and a lot of cool things like that. Bifrost is a plugin that comes bundled inside of Maya and is well integrated with USD and with Arnold. Additionally, Bifrost can be executed outside of Maya using Bifrost SDK, and it can also be integrated in other DCCs like Unreal or Unity or any other DCC you might be using. In short, Bifrost is a powerful and versatile procedural tool for any 3D content creation need. So let's talk about some core features now. And first up, we have procedural world building. For building large, complicated environments like forest and city blocks, we have something we call ScatterPack. ScatterPack is a collection of high-level compounds to do things like scattering points, creating instancing, randomized rotation, and a lot of cool tools like that. These tools are usable with the rest of the Bifrost building blocks, like volumes or geometry queries or even fields. And Bifrost point instancers are compatible with USD point instancers, so making it even more efficient to build large and complicated environments and render them. We are also continuing to explore and support procedural geometry tools. In this video, you can see using Bifrost USD tools and features in Bifrost like property transfer, component tags, extrude. You can build really large, complicated environments and scatter all the buildings like shown in this video. Now, Guillaume will be doing a deeper dive into how to use some of these tools to build your own environments and then bring them into Unreal. And next up, we have texture maps in Graph. And it's one of the latest additions we have in Bifrost as a new feature. And as you know, texture maps can be used to control things like simulation, scattering, displacement, etc. And to do so, now our users are able to bring in textures in Graph, read them, write them, manipulate and composite image data, and work with textures with UDIMs and image sequences. So it's very versatile, and like I said, now in the advanced feature, you can also generate texture maps in Graph, like wet map or the one you see on the screen, the soot map. And you can also generate, for gaming, vertex animation textures, and Guillaume will be showing you some of that. And let's talk about simulation now. Bifrost offers some of the state-of-the-art simulation solvers. And first up, we have Aero. Aero is a versatile, physically based fluid solver, and it works great for things like combustion, explosion, dust, smoke, fog, etc. Next, we have MPM. MPM is a hybrid particle in-cell technique, and it excels in materials that are in between liquids and solid, like this snow, mud, ketchup, chocolate, and you name it. And then we have liquid solvers. It's one of our latest additions in simulation solvers, and it comes with things like foam, spray, and meshing tool. Now, this feature is only available in beta, but it can do large-scale simulations like oceans, waterfalls, rivers, and a lot of cool things like that. And then we have particle systems. And unlike the other solvers, it's cheap, cheerful, real-time kind of solver, but it really works well with the other solvers as well. Now, rigid body is the latest addition to Bifrost simulation capabilities. I do want to put a disclaimer here. It's only in beta, and it's super, super early stages, but our game customers have been asking for this feature, and we're very excited to share that it's in beta, in very early stages, and we are working on it now. So what we have done is we have started with integrating Bullet Solver in Graph. And as you know, Bullets is a very versatile solver. It's efficient, it's open source physics engine, and it's used widely in our industry. So that's where we have started, but a lot of cool new features and updates to this are coming soon. Now, let's switch gears a little bit. Bifrost also offers a fully modular and procedural motion system with all kinematic parts of the rigs, like skeleton, constraints, IK solver, and a lot more. With procedural rigs, you can do things like adding joints or removing joints in a joint chain. And also, if you want, you can add and remove arms in a character, and it won't break your rigs, and you won't lose your animation, so it's all procedural. You can also create procedural animation, like shown in this video, where character follows the aim and adapts to the changing terrain, all automatically. These procedural rigs and animation workflow can be really powerful, especially for games. So I encourage you to take a look and check them out. Now, talking about animation, Motion Maker is a new animation feature in Maya's latest beta. It uses machine learning to assist animators by creating realistic in-between motion. So in this example, what we have done is the one on the left, we have auto-animated the character using a guided curve, and it adds the walk cycle automatically using Motion Maker. And then we have brought it into Unreal using the live link. Now, why am I showing you this cool new feature from Maya, which was machine learning feature? The reason is my machine learning prototype for this feature was originally done using Bifrost nodes. And as soon as our users got to know this, they wanted their hands on these nodes to start experimenting and building their own neural network. So that's exactly what we have done. We have delivered the entire ML pack in Bifrost now, with things like layer multiplication, activation function, utilities for normalization, and compounds for reading and writing NumPy data right in Graph. And because we know it's a new domain and will require some training, we have released a series of tutorials on our Maya Learning channel, accompanied by browser graph examples. It covers generating training data in Bifrost, training this neural network in PyTorch, and then deploying the same network back in Bifrost. And also, although this example, the one you're seeing on the screen, is focused on rigging, and it converts FK rig into an IK rig, the same workflow can be applied to things like motion generation, mesh deformation, fluid simulation, and you name it. Now, for Bifrost USD, Guillaume's going to cover it more in detail and show you some tools, so I'll just give you a quick overview. So what we have done is we have released the entirety of USD API in Bifrost as nodes. And using this powerful USD toolkit, our technical users can create their own USD tools to do things like authoring prims, attributes, creating variants, etc. We have also added some really cool one-click workflows for our non-technical users, and it can do things like creating variants from Maya selection, or hiding or deleting points by selecting just in the viewport, and even visualizing the point instancer and in a colored points in your viewport. So super useful tools, very simple to use in single clicks. And lastly, for our technical users, they also have access to Bifrost SDK. Using the SDK, you can create, modify, and inspect Bifrost objects and nodes. You can also integrate and execute Bifrost in other DCCs, including your game engine editing environments, or even write efficient workflow automation tools for your game engine editing environment. And you can also do things like writing render procedurals, like the ones shown in this video for Hydra, or for renders like RenderMan, V-Ray, etc. Now, as you can see, Bifrost is really versatile and has a lot of cool features to offer. And I can keep showing you more, but now I'll welcome Guillaume, our dev manager for Bifrost, and he'll show you how you can create environment in Bifrost procedurally and then bring it into Unreal. Thank you.
Thank you, Sumira. OK, so next, let's take a look at a kind of real example of what you could do with Bifrost to build a level in a game engine, in a game. So we are going to look at how to create assets, or how to modify, improve assets. So the first part, we will see how to, from an asset generated in an application that is going to output trees as USD files, but those trees are missing some information. So we'll see, it's like, it's not the good shaders. We want to change the shaders to be able to render them in our game engine. Or we want to add extra information. So we'll see how to massage a USD asset using a Bifrost graph. Then we will see how to completely, from scratch, generate new assets using the Bifrost graph, like rocks, procedural rocks with a lot of details and controls. From those two assets, like actually a series of trees and a series of rocks, we will also scatter those things using the scatter tool Sumira mentioned. We will scatter them on the ground, on the terrain that will also be generated by Bifrost. And finally, we will save that using the USD tool. It will be saved as a USD file. So little parenthesis. Here, the workflow is using USD in this scenario. But for your information, you can also save on disk Bifrost geometries as Alembic file. Or even you can send the Bifrost geometry to Maya, and then you got access to all the Maya export tool. But if your game engine supports USD, that's the most straightforward way to create a pipeline between Bifrost generative proceduralism and not generative, sorry, Bifrost proceduralism just and your game engine. And to conclude also on the game scenarios, I will show you the vertex animation texture graph that is showcasing the latest feature, like ability to write texture on disk. That is still in beta, by the way. So first, the tree asset. So it was a series of trees, as you can see here, generated with a Plant Factory, that is a free software that can output USD, but it's using NVIDIA MDL shaders. And we wanted to convert those shaders that are described inside USD as USD shaders. We wanted to convert them to Material X. So we use a graph for that to find all the shaders, find all the textures connected to the diffuse colors, etc., and create a matching Material X shaders, an open PBR, actually. Then we'll also replace the leaves of the tree because the tree is using cards, and we want to render the real leaves. So in Maya, we will model some leaves and replace in the USD file, in the USD stage, in memory, we'll replace the leaves. Finally, we will also add extra information. So we want to scatter our trees, and we want to have a sense of the size of a tree to avoid interpenetration between trees and rocks and grass. So we are going to add a simple attribute that is a radius attribute, a USD attribute, just to showcase how you can create a USD attribute with Bifrost. We could also use more advanced techniques like looking at the volume of rocks, but here it will be very simple for this presentation. And in the end, we will see how to save the USD asset to disk. So first, I wanted to show you how it looks at the graph level when you express USD nodes to construct your stage. So your stage will be your level in your game editor. Here you can see that we create, so the create node, the create stage, allow you to create a new USD stage, and you can open or create layers. So the first layer here, it's an open layer. We are opening the tree generated with Plant Factory, the free software we are using. So it's the tree non-modified, and then we add overrides like layers on top that will modify the tree. So the first layer is to store the material, the new materials, and the next one is to store the new leaves. Finally, in this graph, we can see we target the material layer. So it's a node that is shipped with Bifrost that allow you to say, okay, in my USD stage, I want to work any operation I will do downstream the graph will happen in this layer. It's a USD concept that is available in Bifrost. So let's take a look. So here we can see the tree from Plant Factory with the cards. And you can see on the left in the outliner the USD hierarchy. And we are replacing the cards by real Maya mesh, Maya leaves. So you can drag and drop your Maya mesh into the graph, and you can connect them to the compound. So this compound is not shipped with Bifrost. It was made as a demonstration of what you can do. So you can build a quite complex system that will search the point instancer in the USD file and will replace things. You can also find all the geometries and try to find the width of your and the size, in short, of your tree, and store this information as an attribute for both, in this case, for the trunk. You can see there's a little circle to visualize the trunk, and for the tree. So the attribute that we are storing for the trunk is to avoid rocks that are close to the trunk to interpenetrate with the trunk. And the large circle is for the trees, in between trees. So we are going to dive a little bit in this graph. Here it's the compound showing how to modify, to replace the leaves that are cards by real leaves. It's not all the nodes. In those compounds, you can have more nodes. So here I'm just showing the high-level view of this compound. But you can see that there's an input. I don't know if it's big enough. There's an input to get a Maya mesh and you connect it to a compound that is going to find the cards in the USD asset and replace it automatically. And then there's also native USD nodes in Bifrost to hide existing USD mesh, like the cards, we don't want to see them anymore. They are used as old USD prototype, we want to hide them. From this compound, so if you look at here, you can see the compound name. And here it's a node, so it's very small, sorry. Yeah, so here we see how to create a USD attribute. So this native node creates a USD attribute called tree radius. Then in this compound, we find the mesh, all the meshes of a tree. And actually, the tree is relatively complex. It's not just meshes. It's mesh for the trunk, and then instances of each leaves, it's a point, and each point references a model of a leaf. That is the card. So we can analyze with the Bifrost geometry node very easily. We can analyze everything and figure out what is the bounding box of a tree, basically, or what is the width of a tree and the depth of the tree. So we store that in the USD attribute using the set USD attribute node. We do the same for the trunk radius. Another aspect that is very interesting is that there are some native tools in Bifrost that allow us to move from a point instancer, so a structure with some points and some model that you want to instantiate on your points. We can move from that to one mesh. And we can also convert a USD instancer, USD point instancer to a native Bifrost point instancer. So using this tool, we can merge everything in one mesh and then use Bifrost volume tools like mesh to volume and volume to mesh. Those nodes allow us just to reduce the resolution very easily. So you create a signed distance field of a mesh, and then you can reconvert back to a mesh with a lower resolution. So procedurally, you can generate a lot of trees with all the representation, the low-res representation. So this compound here, I don't know how it is called because it's very small on the screen here, but this compound is, if I go to the next slide, it's this one. So this compound output a low-res version of a tree. And we connect it to a node, a USD node that is creating a USD mesh. It's parented under a prim that is called proxy something. So we do that for the proxy, and we do that also for the guides. So we've got two representations. One that is just a bounding box, and the other one that is a low-res tree. Next, the rock asset. So this time, we generate everything in Bifrost. You can guide the generation with some Maya geometries. For example, you can connect a sphere. In this example, we are using a sphere. But you can use a cube or whatever shape that will sculpt, that will set the initial shape of a rock, the initial silhouette. And then you got a lot of control. And finally, you can extract a normal map. So in the game engine, you don't load the high-res rock or rocks. You just load the low-res with a normal map. And the normal map graph, the graph to generate it, is also in Bifrost. Super quickly, for those that are not aware, a Bifrost graph is compiled, so it's quite efficient. Instead of writing a normal map tool in C++, just use a graph, and it will be as efficient. So the rock graph, we can see in the viewport, here it's the high-res mesh. Below it's the high-res mesh, but we assign just the normal map to check it. And the first node here creates the rocks, and the second one convert to USD. Inside the rock, the create rock, here we can see that we have, so it's the compound generating all the rocks, and an interesting feature in Bifrost, you can connect to an input an array of things. So if you connect an array of objects, of like a mini sphere, box, etc., it will generate as many rocks, and in parallel, automatically. You don't need to think about it. It will be computed in parallel. The normal map graph, so I did not dive in this graph. It's quite complex, but it's entirely done in the graph. So we generate a texture in memory using the new Bifrost texture node, and we write them to disk with not yet released in beta write texture node. So the normal map take the low-res mesh and the high-res mesh, and yeah, you see the settings. You specify a file, can be XR, or we support all the common file formats for image, for textures. So here's the result in Unreal of one rock. So you can see the low-res with the Unreal shader, with a normal map applied. Here it's the Unreal shader with a normal map applied and a diffuse color also, a diffuse texture. And it's the same here, but you can see the low-res wireframe on top. Finally, when we've got our assets, we are ready to build our level. So here you can see that this graph is relatively simple. Inside, there's much more nodes, but you can share this asset, this graph, with your artist. And even an artist that is not super comfortable with Bifrost will quickly be able to generate a lot of variation of a level. So the first compound creates the ground, the second one creates the trees, the rocks, and export to USD. So let's take a look at it. So in the first compound, we generate procedurally a ground using Bifrost noise. So there's a lot of variety of noise in Bifrost. In the second one, we scatter trees, and we can compute the slope of the terrain and just pick an area where we want the trees, and we can also control the density. We can display the density using a density map. You can also get information from Maya inside Bifrost, but here it's entirely in the graph. Here we scatter the rocks, and since we've got multiple rocks generated, we can pick one, or we can randomize and have more rocks that are scattered to get more variations. Finally, we are going to look at the grass, I think. Yes, so we can isolate in Bifrost each geometries easily with the terminals node. And here we can see that we deleted the grass inside the rocks. We can also variate the seed for the whole thing. So you got a new level with completely different position for the tree, for the terrain, etc. And when we are OK with the result, you can convert it to USD and generate native USD data. So in the hierarchy here, you can see there's meshes, there's point instancer, USD point instancer with some prototypes that are referencing your rocks that are on disk, that were generated and saved using Bifrost USD. You can also do things like converting the grass. The grass was generated as strands, as curves. And the game engine we are using in this example, it's Unreal. We could not figure out with the USD importer loader how to render grass as curves. So we convert the grass to meshes. It's something very easy in Bifrost, so you can see it here, it's mesh. When we load in Unreal, we just load one file. So this is where USD, I think, it's very interesting, because the whole level is one file, one USD file. So you can change things in Bifrost. You just save your stage. You can even keep the save check mark in Bifrost active, so any edit will be saved. And in your game engine, you reload, and you will see the new result. It's concluding the small level demo. The last thing I want to show you is not that, but that, the vertex animation texture. So here again, it's a compound we just made in the graph. There's no programming, there's visual programming only. There's no C++ or Python. Is it playing? Yes. So it's generating a vertex animation texture describing the position of the meshes in time. The interesting thing is that you can deform anything that Bifrost can deform, including Maya deformation, because Maya geometries can be connected to Bifrost. So here we are using PaintFX, a tool that is used since many years in Maya, and PaintFX can be rendered in Unreal as a vertex animation texture in a shader. For the water, it's a Bifrost ocean shader that is used. And I think it's concluding the quick tour of what is Bifrost. how you could use Bifrost in a gaming environment. Some additional information. So we've got some great learning resources. So you got the Maya Learning channel. Feel free to take a picture of the QR codes. And we've got also a great community channel, not managed by Autodesk, called Bifrost Discord channel. Very friendly, and if you've got questions, if you are curious, just ask questions on this forum. It's very dynamic. People are answering usually quickly. So yeah, plenty of way to learn Bifrost. There's also the documentation that is attached to each node. So in Bifrost, each node got a tab called Info, and you can take a quick look also. Thank you, and if you have any question, I think it's time for Q&A.
Hello. Thank you so much for your lecture. It was really informative and really just beautiful to see all these rock, tree, water textures in Unreal and Unity. I'm curious, I'm working on a game in Unity, and we need to do a lot of fluid mechanics, as in rivers, waterfalls flowing in and out of ravines. And I was wondering, how is the process to use your fluid Bifrosts in Unity?
Okay, interesting question. I'm going to try to give you two answers. So the first one, it's what I show you, it's the vertex animation texture. Actually, it's a powerful technique, I'm sure you know it much better than me. You can use mesh that are varying across time. So you can generate a Bifrost fluid, mesh it in Bifrost, and save it to disk. And you can then animate the texture, well, load the texture in Unreal, the vertex animation texture. So it's a way to use fluids animation in Unreal or Unity or any other game engine. You can also, but this one is more involved, if you have developers, you can run the graph directly in your game engine. There's an SDK, as Sumira mentioned. It's relatively straightforward, actually, and surprisingly simple. You just need to implement the translation between your game engine and Bifrost. Use the same graph that you are using in Maya. You can load it with this API. Bifrost will run, will generate this data, and then there's a translation phase to give it back to the game engine. In the editor only. We just support game editor, not the game you are shipping. So yeah, that's two solutions you could
Thank you so much. Thank you.
We do have some users who have done SDK integration in Unity, and they have made the code open source. So check it out, see if that works for you.
Thank you so much.
Oh, cool. Hello, I'm CJ, and I'm an environment artist. First off, really, really cool presentation. Love seeing the whole Bifrost stuff. This is the first time I'm completely introduced to this whole new thing. My question to you guys is, one thing that I'm really curious about from what I saw in the presentation is, with the rocks, I noticed that when they were placed into the scene in Unreal, like the geometry like completely like deleted underneath it to have like optimization, which was really, really cool. So I'm curious to know where it's like, does it like permanently like stay, and when you like remove the rock, like underneath like the geometry is like completely gone, or can you move it anywhere around the scene and like it'll like compute to where it's like you can move the rock all the way down and then like all the geometry deletes, and then if you can like Control Z and then pull it all the way up and then have like other geometry deleted as well?
I'm not sure to follow exactly. The thing is that there's the USD side. When it is loaded in Unreal, then it's translated to Unreal geometries. And this part, it's up to Unreal to manage it, how they are managing this thing. So I think your question is how to update or to...
No, yes.
Yeah, so there's multiple ways. On the USD side, what you can do, you don't need to always export the whole thing because it's USD. So if you want to, let's say, to update one transform on a rock, you can, in the graph, add a layer, set your transform in this layer. and then reload the stage. And so the data on disk will not change except a small layer added. But on the Unreal side, it's up to their implementation to reload the whole thing or to just reload the layer when they translate back to native Unreal. So this part, I can't comment on that.
No worries. Thank you so much. Really appreciate it.
I can add a little bit to that. You could, like, if you want your translation of the rock to change how the grass is deleted or how the ground interacts, you could build logic inside Bifrost graph. So as soon as you update it in Bifrost, then your Unreal scene is, or it's all automatically updated as well. So you could build that logic inside Bifrost graph.
That's really cool. Awesome. That's sweet. Thank you so much.
Hello. Oh, hi. Thank you so much again for the talk. It was fantastic. Right off the bat, I wanted to ask specifically on the vertex animation stuff. I understand the function behind it and everything else like that, but where does it really stand itself out compared to inside of Maya, using Maya and just changing the vertex color on one thing and then adjusting that inside of Unreal and using the material editor to do almost the exact same thing? Where does this one stand itself out compared to just doing the wind animation node inside of Unreal?
I don't know. Actually, I'm not a game expert, so I know that vertex texture animation, V80, is used a lot as vertex shaders. Well, I don't know. Actually, I know. Sorry. Yeah, it's animation. So you can have you express the time on one axis and the position on the other one. So with a colored vertices in Maya, it's tricky to manage the time. So yeah, you can deform, but in time, and if a topology change, like a fluid simulation with remeshing, yeah, it's very, very maybe possible with some devs working on the tool. But in Bifrost, you can quickly design a compound that will just do it with vertex animation. But vertex animation texture is not something specific to Bifrost. It's a famous technique in the game industry, so I guess there's a reason for that. I have to confess, it's not my industry. I'm coming from VFX. But yeah.
No worries, yeah. It was just a simple thing. Sorry about that. Thank you so much. It was a wonderful talk.
Thanks.
Thank you.
Hello.
Hello. Here.
Hi, I'm also an environment artist, so your demonstration about to generate the tree is really amazing. So I'm a little bit curious about if there is another way to create other type of the vegetation, such as to create ivy or other things.
Sorry, can you repeat? I missed a couple of...
The mic is echoing a little bit.
There's some echo.
I mean, if there is other ways to create other type of the vegetation, such as the ivy.
Yeah, so Bifrost, it's a visual programming language, so it's quite open. So if you want to create, so the vegetation here, the trees, were not created in Bifrost. We were using another application, just to showcase that we can also modify things. But we could also design, and some of our users made some L system-based plants in Bifrost. We don't ship anything with Bifrost, but the graph would allow you to design and build your own tool. So if you want to do something like a generative, a procedural tree, there's plenty of way to do it in Bifrost.
Okay, thank you.
Hi, thank you for the talk. I'm a technical artist who does tool development in Maya, and I was wondering if Bifrost was compatible with Mel in Python?
Yes. So just Mel commands, so equal Python commands, Python.
That's great, thank you.
Yeah.
You mentioned at the end of the talk that the grass information had to be converted to mesh geometry because there was no way to specify curves in USD. Is there any plan to collaborate with the Alliance for OpenUSD to extend the standard with that?
Yeah, actually it was in Unreal. USD support curves, so first we saved to USD as curves. We could load it in a USD view, in Maya, but in Unreal with a USD plugin I was not able. But I'm really not an Unreal specialist at all. So maybe I was missing something. So
it's on Unreal's side to add support for that?
Maybe.
Okay.
Dang, I had two questions and I just forgot one of them, so it might come back to me. First question is, I'm not entirely sure yet I know that there's AI being driven here or machine learning driving this, but how does it differentiate itself from Houdini, Unreal's procedural generation content system, or say geometry nodes that I think are found in Maya and in Blender? Like, what is the key features empowering more generation, smarter generation compared to those tools?
That's a tricky question, but I'm going to try to answer. So first, I'm not comparing Bifrost to any other application. The power of Bifrost, it's the flexibility because it's a visual programming language. That's all it is. Other application could be more specialized for some specific tasks. Bifrost, it is, you can express pretty much everything. And we expose more and more building blocks to allow you to build more and more advanced system. So yeah, it's one of a procedural system. It's quite focusing on that, just proceduralism. It's a little engine you create a program using a node graph, and you ask Bifrost to execute your program very efficiently. This is what is Bifrost, and it can run in multiple applications with an integration that we are calling translation table, so we can integrate in the host application like Maya.
So just to make sure there's no ML-powered aspect to it?
So you can add ML to Bifrost. You could have, Bifrost is extensible also. So you can write your own C++ node.
Sure.
That's the simplest API that I know, because a C++ function or a C function can be called in Bifrost very easily. You just need to build with a specific recipe that we provide in the SDK. And so it's very easy to expose your own functions that could call machine learning things.
Okay, and I just remember another one, which is how does this the licensing agreement work in conjunction with Maya? Is there, especially for indie devs or something like that, or is it available for free community, non-commercial use or something like that?
Sure. I want to add to your first question first. Like, I believe, like, again, not comparing to the other DCCs or anything, procedural DCCs, but if a lot of your workflow is in Maya, Bifrost is super integrated with Maya. So that's one of the major benefits you have, right? Like, if you're doing other geometry stuff, or if you're doing your animation in Maya and you want to bring in that into Bifrost, it's literally inside Maya. So it makes it really easy to work with your other Maya workflows. So that's one differentiation there, which I find really super useful. And like he said, it's kind of open in a way that you can build your own tools inside Bifrost. And to your second question, it's a plugin that comes with Maya for free. So it's no additional cost. There is a certain limitation on execution of how many you can execute outside of Maya, but there's no limitation of using Bifrost inside Maya.
Thank you so much.
No problem.
Hi. Thank you so much for the talk. It was really informative. I was just curious about the rigid body dynamics and the bullet solver you guys showed in the beta. I guess the question I have is, it might be possible to do this now, or if it's going to be possible in the future. Mm-hmm. Could you bake the simulation from like a rigid body dynamics to a vertex animation?
Yeah. Okay. Yeah, it's a mesh with varying topology or not. You can also pre-shatter. So yeah, definitely a good candidate for vertex animation.
Okay, awesome. Thank you.
No problem.
Thank you very much, everyone.
Thank you, everyone, for being here. We will be here if you have any questions.